Now, welcome everybody. Today, it's our second day for our NMOS Daily Math Doses. And today, we're going to be covering on the topic of half models. So I hope that before you're doing the questions that's provided in the PDF, please make sure to read through our knowledge points for today. So today, we have a few things that we're going to be covering. Our table of content as shown over here, our different types of half models, and also the method of drawing extra lines to help you solve some questions. And later on, don't worry, we still have an extra practice from the NMOS book itself. Now, our different types of half models, as we notice over here, our rectangles can actually be cut into two equal sections where you have your triangle as shown below. Because remember, the formula for a triangle, half times your base times your height. And the base and height is just as if it's like your length and your breadth for the rectangle. So the breadth and length of the rectangle itself, okay, multiplied by half, you get the triangle. Since the triangle always is half of the figure, this means that in this case, we can just take the area of the rectangle divided by 2. And in fact, all of these same shapes over here would have been doing the exact same thing. As you can see here, this triangle, draw a dotted line down, half of this rectangle, half of another rectangle. Even this triangle, the same like the first one, we extend it out a little bit, but the height is still going to be the same as your rectangle. The base is still identical as well. More of these figures can be cut, so on and so forth. So as we try to go and look at each of these figures here, we will understand that all of them would have been half of the figure. Maybe in particular, I would like to point over to one of these figures, the one over here. Okay, there is a little hint here. Maybe you can be using this for our DMD later. Now, for this particular figure, if we drew a line across like this, we have your height, H1, and your height, again, H2 for each of the triangles. Now, if we were to combine these two triangles areas together, we actually get half times your H1 times your base. And it also happens to match with the base of the other triangle at the bottom. Half times H2 times the base. We combine them together, we're going to give us half times H1 plus H2 times the base. But we also happen to see that H1 plus H2 does give us the height of the rectangle. So in this case, it is still half times your rectangle. And like I said again, very helpful in one of our DMDs questions later. So let us continue on to our later parts of our topic. So here we have your triangles, where triangles, if we actually draw your A, B, C, and you have D being the midpoint of the triangle, because the base of both triangles are the same and the height is also the same. And that's the reason why both triangles will have the same area. It's still cutting one figure into two equal portions. The trapeziums as well, with the same reasonings, okay, for all these little figures. Okay, hope that you manage to do your own practices to be able to see how they are half models as well. The last part, quadrilaterals. Even quadrilaterals, when you have some very odd and irregular shapes inside, we can still actually see that they are half models as well. And I want to point for one particular figure later on with a little bit of detailed explanations. Let's move over to drawing extra lines. Because sometimes just by drawing some extra lines on the figure, we can actually tell that this is going to be a half model question. So this figure, it may not look immediately that actually looks like a half model. Maybe some of you will be like, yes, tilt the figure a little bit here and there, cut them into smaller pieces or whatnot. I'll tell you, there is just 4 extra lines that you need to draw inside. All you need to do is to add this, okay, one of these lines inside. Okay, sorry, these few lines inside. And it will look very similar to your A, B, C being cut by the midpoint of D. So you look at this D over here, and you try to visualize it within this shape. 1, 2, and 3. Doesn't it look oddly familiar? So it's just like the same triangle with that midpoint given over there. And because they both have the same bases and the same height, that's the reason why you have half of this triangle being shaded. But what about the rest of the figure? Same thing. The bases they are equal, and the height are the same. The bases are equal. Sorry. Okay, and never mind. The bases are equal, and the heights are the same as well. The bases are equal, and the height is still the same as well. So that's why each of these bigger pieces of the triangles is cut into two equal sections. One is shaded, and one isn't. So from there, you should be able to see that this entire figure, only half of it is shaded. It's again another half model for you. So let us move on to our next part. Okay, our topic, our questions for our NMOS book itself. So our practice questions here. 2016 paper on a preliminary round question. Now, when we observe this figure itself, it may not be immediately obvious on what we have to do, because all we are given here is a square and a rectangle. Now, your square, in this case over here, what can we do with it? And how is it related to your rectangle? So like I said, sometimes by drawing some extra lines, we can visualize your half models. Now, the square, we want to actually have a triangle inside, right? So that we can kind of visualize a sort of like a, in this case, okay, we try to visualize a triangle inside a square. The same base as your square and the height being the same as well. So we can have it as half. Let's try to figure on out. In fact, actually, we do have one. Like this. Because if we see here, EDC, the triangle EDC over here, this happens to be half of your entire square. Which square are we talking about? It is half the area of your EDGF, the whole big square. But coincidentally, it applies somewhere else as well. Where else? Okay, if we look at it a little bit shaded figure now, we observe it with your triangle EDC being also the half of, doesn't always have to be square, it can be half of your rectangle as well. So it can be half of A, B, C, D. Now that we know that your triangle EDC is half of your ABCD, all you need to do is just to go and figure out how we can relate this section with the section below. Now, from here, let us go and observe your EDGF. Do we have the area? We do, because your triangle your square EDGF equals to 160, because it's the side length of the square times 160, giving us 25600 cm squared. And it also happens to be the same as, half of it would actually give us your triangle EDC. But at the same time, since triangle EDC is also half of your triangle, your rectangle ABCD, so coincidentally, our area for rectangle ABCD will also be the same at 25600 cm squared. Now, that's the entire rectangle's area, and we want to link it to the AD, length AD, given over here. This is the base of the rectangle. Sorry, this is the breadth of the rectangle. And do we know the length? We happen to know the length. The length of your ABCD times your breadth gives us 25600 cm squared. And your length is given earlier on. Over here is your CD, as stated, 200 cm. So your length of 200 times your breadth gives us 25600 cm squared. We can find the breadth of the figure just by dividing. Divide by 200, your final answer 128 cm. And just like that, using your half model, you can observe that the triangles is half of the area of the square and also half the area of your rectangle. And this allows you to find the breadth of the figure. So the breadth of the figure, 128, also the same as the line AD. 128. Now, with one last thing to mention here, in your daily math doses, please make sure to complete all 3 questions. Even if you're not very sure, please try it out. Because what better way than to practice? This will help you a lot more for your NMOS competition. Remember as well, send your answers inside the dedicated group chats. And last but not least, take note of the solutions that will be sent out the next day as well. Okay, thank you everybody. And we'll see you again for the next round of your DMD questions.